Hello, hello, hello. Yep, I think my audio is good. So, yeah, I'll try to explain this problem. Yeah, so the basic idea that I thought of basically, right? So, we are given A, B, B, and we have to find a anagram, right? Minimum anagram which can concatenate and kind of uh, give us the whole string, right? So, this is a one one example. So in this, the answer will be AB plus BA, right? Because these two are anagram, and if let's say I take AA, this is not an anagram. Like this is one of the anagram, but this is like of length 4, right? But to understand it in a better way, we'll take example of this, right? So here, let me make it even, right? I think for odd, it will not even work. Yeah, for odd there will be either one length anagram. Yeah, if the length is, for example, 5, right? So there is one thing in anagrams that they have to be of equal length. For example, AB is anagram of BA. They both are of equal length, right? A can't be anagram of BA, right? Because they need to have same characters. If the whole length of the string is odd, then I think either one could be the answer. If let's say it is A, either one could be the answer because just because these are all same, right? And A is anagram of A. So, but if let's say there is one different character, A, then you have to just return 5 because then you can't kind of get an anagram which can be concatenated, right? But that's a separate case. Now, let's say we are given this, right? So now the n here is 6. Now, in this, there could be the anagrams could have, my bad, man. Sorry, I'm not used to this, so my bad. So this was what I was explaining that if you have odd length of age, right, then either you could have one or you could have all 5, right? That's the only possible solution. You can't say that if I make this B, right, then you can't say that B is anagram of A, right? There will not be anagrams that can make it equal. Now coming to the case that kind of gives you the intuition, right? Now, there could be, you only need to have divisors, right? So, for example, if I have to find which could be the minimum anagram, right? Either it could be of length 1, let's call it L. Either it could be of length 1 or L could be 2 because you will say that I'll take this 2, I'll take this 2, and then I'll take this 2, right? Then that's the another thing, or other could be L is equal to 3 because 1 is also divisor of 6, 2 is also divisor of 6, 3 is also. But now if I say can L be 4, right? It can't be 4 because let's say you picked this one, then you can't concatenate whole of this, right? It will go out of bounds. So that kind of is the first thing that I thought of. Then if you see here, right? So maximum number of factors of any 10 raised to power 5, which is our like the maximum thing here, right? uh, could be 100, close to 100, right? So then even if I try, for example, if let's say n is 10 raised to power 5, right? Even if I try all the factors, I'll try for 1, I'll try for 2, I'll try for 3. So there will be maximum 100 tries, right? And then I'll be looping over this. So that will come around 10 raised to power 7, right? Now 10 raised to power 7 is basically and so basically what this means is if you're doing 10 raised to power 7 operations in 1 second, then it can pass, right? That's the computational power. So that's why when there is like 10 raised to power 2, then your n square operation will work, right? So that's where I thought that okay, this may work, right? So that's basically what I did. So what we are doing in the code is that, so you are checking. So first of all, here you are checking whether your I is dividing it. If it is, then first you create your initial thing that okay, this is my subset. So in the first example, A, B, B, A, first I'll check with this. So in the first example where we have A, B, B, A, right, I'm going to check with this. Now here, what I'm going to say is the okay, my frequency array has A, like this initial array. It will just has a count of A, right? Then I will take another this element and I'll say that okay, is it same? It's not same. So then you'll break it there only. You'll just return n because n anyway will be the answer always. Because it says that in this like a t can be equal to s, right? So in this, it will not work, but then we'll pick AB, right? In AB, your array is going to look like this, all are zeros, and your first element will be one. So this is your A, this is your B, and rest all are zeros, right? So then you are going to check this with this, which is basically the same, right? Then it will match, and then you are going to return 2, right? So if I try for A, right? If I try for A, it should give me 1 as an answer. Let's see. Yeah, it gives one an answer, and to prove the other point, if I let's say give A, B, and A, right? This should give 5 an answer because it is odd and it's not of all the same elements. Yeah, yeah, that's the intuition behind it. Let's read the hint. I think it should be same thing only. Yeah, the answer should be divisor of first. I'm glad. That's the first thing that I thought. Right? Check is okay. So the same thing, the exact same thing that I did. It's the same thing. Cool. Right? It's fairly easy. People would have commented that it's a okay. Yeah, that's it. So going to pick another problem now. It's a good problem, so probably give it a like because this is the first intuition that would come to the mind, and then this is the second intuition. Okay, let me explain you the odd case. So basically, in odd numbers, right? I think. No, I think I might be wrong. So let's take an example of A, A, B, right? Yeah. So that they ignore the odd case. It's not important. So yeah, because I confused odd with something else. So here the length is odd, right? Oh, no, here also the length is even. 9 is odd, right? A, B, A, B, A, B, A, B. Yeah, right. What I want to kind of say is that if you pick 3, yeah, in A, B, A, so in this A, B, A, right? So in this, right, the in this, the length is 5, right? Now, first thing that they say is that it should be divisor of this. So, for example, it should be 1, or what else divisor it has? 5 is a prime, so it just has 5, right? In this, these are the length of your valid anagrams. Now, each letter is not same, right? Because this A is different from this B. So, you can't say that A is your anagram, right? Now, that's why here the answer would be by default 5. But if let's say it is right? In this, the answer is 1. Why? Because all the elements are same and it is of length 5. Like, doesn't matter whatever is the length. If all the characters are same, the answer is 1, right? Because A is anagram of A. But what I said might be wrong in a scenario when the length is 9, for example, right? Because 9 has a divisor of 9 has divisor 1, 3, and then 9, right? Now, in this 3 could also be the answer. So, what I meant was basically prime. If it is a prime, then only it has two divisors, right? One and number itself, right? If the length is prime, in this case it is prime, and all the characters are not same, then your answer would be the prime number itself. That's the thing. But it might not be the case in odd. Why I'm saying this is because let's say you have 9, right? Now in 9 your length will be A, B, A. Let's say this is our first uh, anagram. Now I'm going to create another gram, B, A, A. This is also anagram, right? Then I'm going to create another one by saying uh, A, B, A. This. Now here the length is odd, right? So the length is odd. Initially I said that the answer could be 1 or 9, right? Which is wrong. Here it could also be 3 because the divisors of 9 are 1, 3 and 9 itself, right? Our worst case answer is 9, but our best case answer could be 1 or 3, right? Now, is it 1? Because if it has to be 1, this is our first pick. The second pick is this none, which are not same, so 1 goes rule out, right? Now, the next pick that I can have is 3. So here I'll say that, okay, this is my second, the 3 pick, which is like 2 comma 1 and then rest everything is 0, right? Now here again this will be 2 comma 1, right? Here again this will be 2 comma 1. So here 3 is the answer. So let's try this out. It should be 3. Uh, so the thing that I mentioned for that is wrong. So basically A, B, A. So A, B. So basically A, B, A, B, A, A, B, A, right? So here the answer should be 3. Yeah, answer is 3. Yeah, correct. So kindly ignore the, let me put a comment if anyone else is, kindly ignore the odd explanation. Stupid thing to say. Cool. I think that makes the problem clear. So basically, the two hints are kind of what I did. So I'll probably move to another problem. So I want to pick another. Which was this problem? Minimum length of anagram, right? Minimum length of anagram. Okay. So basically Q3 of 396. Minimum set after removals. I'll pick this one. So what my aim is, I am solving all the Q3 problems which falls in this range of contest. That's the aim if anyone is listening. This problem I think I've done. You are given 2 and mm, again I'm at This I think I've solved. Yeah, this is a good one. Hmm. So given a string S, you need to partition it into one or more balanced substrings. A balanced string is where each character in the string occurs the same number of times. Each character in a string occurs the same number of times. For example, if S is equal to A, B, C, C, then A, B, C, C. Each character where each a balanced string is a string where each character in a string occurs. It is A, B, C. Here C occurs 1, here C occurs 1, here A occurs twice, B occurs twice. Right, so all these are balanced substrings, right? And we have to find minimum. So like I can't put all these in one because then C is occurring. Why can't I do that? Okay. Yeah, no, no. So A, B, C, C, and also A, B, C, C. Then A, because B occurs twice, A, B, A occurs where all is, okay, each character occurs the same time. So here A occurs one, B occurs once, A occurs once, B occurs once. Here C occurs two, here C occurs two. Why this is not a valid one? Valid partitions are A. Okay, I think this is also valid, but the minimum is 3. Now, 1 is not an answer, I think. Can you do it in 2? That is the question. A, B, C, C. Can you do it in a 2? Each character should have same frequency. When each character could have same frequency. If you have this right, so every point you can break, right? You can break if so the maximum could be again n. It could be A, B, C, C, right? This is the maximum answer. Maximum partitions. Now the minimum partitions where each character has the same frequency. It could be like this. This is the one of the minimum where we are saying that okay, so our aim is to take as many string as we could, right? Where A has 2 and this whole B also has 2. So basically our frequency element, all the elements other than 0 should be same. So like this, right? Here it is 1, here it is 1. That is the aim, and then we have to minimize the number. So ideally, you could break it whenever you have a same number and then start a new array. Hmm. What are the constraints? Constraints are little bit light. And is to power 3. Uh, Constraints are 10 raised to power 3, so I can think of an n square solution. So n square will work. Okay. One thing that I can think of is you can break it if you're at each point you have to make a decision whether you want to break it or not. Feels like a DP problem. So let's take this example. F A B C D D E G, right? 0 1 5 6 7. So at each point I need to check whether I can break it or not. I can break it. No, I can go ahead. Can I break it? But how to, if I use a DP, right? So one I have I. That's one thing that I have. The other thing that I have is the whole array of 26 characters, which has the count, which it should be all same. Other than zeros, it should be all same. Basically, size of my hash set should be same. Is sliding window the answer here? No sliding window. No, no, no. If you pick this F, right, your count is 1. Either you have option to break here and then start a new one, or you can say that, okay, no, I want to take this also with me. Then your F has 1, A also has 1. Then you will go to B, take that also. Now, every time you make a choice whether you split it or not, if you make a choice of breaking this, you can say F A B, right? This is your answer. This is your first thing. But the next one, how will you compare the size of each character? And then you have to make sure where you are and where you started. Either you could have that, okay, I and J, you could maintain that you start with 0 and then check. Yeah, I think I and J. But at every step, I would be checking that. So will that also increase? But is that just a 26 bit check? Yeah. Yeah, I think that is just a 20. Let's try it out. It may or may not work, man. Not sure. J is your old index and I is your next one. I is greater than equal to n. Can't go further. I have to make choice. So current is int A is equal to J. A less than I minus 1. A less than I k plus plus. Frequency dash dot where at I minus 1 plus plus. Right. Now max equal to max frequency k. Right. Yeah, right. Whatever is the one that will be the maximum. So then I will check I character is equal to less than 26 plus if frequency of I is not equal frequency of k is not equal to 0 and frequency of I k is not equal to max, that means it is not the same. So basically whatever you came so far doesn't work. So we want to find the minimum number of strings that we can partition it into, right? Teacher dot value by 2, the biggest one, right? Now everything is good here, right till this part. So you will not, if let's say you never came here, then you basically this is your another party, return 1, right? Now you have two options. Option 1 is equal to teacher dot value by 2 and option 2 is dot make by 2. Now first thing that you can do is break. Or first thing, let's say option 1 is that you don't want to break, so you say that is I plus 1 j remains the same. Now the second is that break. If you break, it's a dirty ugly. Now once you have, let's say, done this right, you kind of and break is equal and break is if and break, then you basically do into equal to you break it here. If s remains the same, of broken till I, right? Breaking you to consider I in this I, and you can say your I and your J. If this is because this check is of reversing the whole. Yeah, it will time out. It will time out. but I can fix it, I think. If it times out, then I can fix it. Uh, Option one, two, yeah, it works. Timeout. Yep, cool. So that was expected that it is going to time out. Timeout was expected, but now I can do another thing, right? So the only thing that is this is the timeout thing, right? So what if we, let's say, have this? So basically, then no, I do have a max, right? But it is my I and J are the main things that I care about. So if I get rid of this testing, and then right, and here you will do this check and return. So here to add also. That is what I want to do. Frequency of s dot char at I minus a plus plus, and then you also max f is add dot max f, and then you do this frequency of s dot char at I minus a, right? So basically you have that character and the frequency and max f. Now once you have done this, to correct this also goes up. Don't need max frequency I already have. So then I'm going to do this check. Now here it will going to be new point 26 and 0. That is brand new. This brand, right? Uh, can break check I need. Can break check needs to be there to work. I'm going in and I'm checking that. Now can break check, can it be there? This is also important because you have taken this character particular. Now let's say once you're done that, I need to do minus of this. Mm-hmm. Because I'm changing it here, right? It has to be changed for equal to true. For this it is okay. Yeah. Need a better way. So this is also changing the. Yeah, I think I have enough time. Take a hint. Okay. Okay, I'll try to solve this offline, guys. Bye.